Yeah, good evening, everyone. Yeah, good evening, everyone.
Good evening, sir. Good evening, Happy New Year. And Happy New Year.
So, welcome to the last class of metrology.
Is that the last class of metrology?
Yeah, just a second. Just a second. Yeah, tell me.
Actually, as you told that this is the last class of metrology. So
Yes.
is that last?
No, so this was the last class for metrology. Sorry.
Oh, okay.
Yeah. So in next session, so there will be new topics.
Okay.
So you might know about the surface measurements. You can easily, if you have this understanding on this topic, you can usually get maximum 1 to 2 marks in GATE. So there were regular questions. So there are very high chances in this GATE also, since there were no questions on the last year GATE, but there were questions on the before last year, like 2021. So some of those questions I will discuss if time permits. So let us start with some basics of this surface measurements. So the first one is the straightness and the flatness. Since if I want to explain what is the straightness, it's simply the departure of any surface from an ideal straight line. Okay, and this straight line is like the datum that we take. So there were some systems in which how to consider this ideal straight line or the datum. Then the deviation from this datum line is the straightness error. So these are some of the devices. So in GATE or any competitive exams, they might ask you what is the use of this device or how the straightness is measured. So in that case, you can get an understanding. Straight edge is nothing but it's a visible device with very high tolerances. So we just keep this straight edge on any surface that we want to measure the straightness error, and we will focus on this interface. If the interface is completely filled, so we can get to know that it is completely straight. Or if the interface, if we can see any light passing through, then there was some error of the straightness. Then spirit level, you might know. So it's just one bubble in some liquid, and we'll place this. Suppose I have a surface like this. So I will take the spirit level in which I will get this. So this spirit level will be like this, or the other one. So it will move up and down. This will move sidewise. So this type of spirit devices. So now I am using this here. So I will take one point here. Similarly, the other point here. Some like that. So I will get some data regarding the surface. Accordingly, I will establish the straightness. Then comes the autocollimeter. So anyone remembers how this autocollimeter works? We have discussed this device earlier.
Interferometry.
Yes. So did you remember the formula?
N lambda. D sin t. Is it definition?
So something with the spacing, some delta theta, and the focal point. So if this is the surface, you will have this with the roller, and whenever there is some deviation in the surface, you will get the deviation here also, this theta I am talking. So accordingly, the light falling will be, suppose previously the image is here, now it will deviate upper, below, bottom. So this is the distance spacing, and f is the focal length. Okay. Okay then. Just remember, if anyone remembers, just let me know what is this formula for autocollimator. Then we move to the flatness. So whatever I discussed about the straightness is completely true for flatness, except there will be one dimension more. So in straightness, I will just move in one direction and I will just establish the relation. But in flatness, it is not the case. I have to take at least two directions. 1, 2, 3. I at least need 3 points in order to establish this flatness. So this is also similar. Everything is similar. It will have a datum surface, and how the surface is situated from this datum will give the flatness error or flatness. So autocollimator I can also use for this, for the measuring the flatness as well as straightness. If I am using autocollimator in two directions, suppose in this direction as well as in this direction, so I can get the points everywhere. Accordingly, I can establish the flatness error. But so that is one of the topic. Then so that is all about the straightness and flatness. So now let us discuss about the surface finish and the waviness. So can you give me the basic difference between these two?
Spacing of the spacing, sir. Spacing between the two successive.
Okay. Two successive.
Waviness is higher at a higher level, whereas surface finish at micro level.
Okay. Yeah, that is true. Any other?
The random pattern that which comes on the surface during machining operation
Is surface finish.
related to surface finish, whether it is smooth or rough.
Okay. Yeah. So then how waviness is created?
Don't know, sir.
Okay. Yeah.
Sir, am I audible?
Yes, you are audible. Please speak.
Maybe due to some inclusion or something.
Inclusions. Okay.
Vibrations in machine parts.
So vibrations in machine parts leads to which one? Surface finish or waviness?
Vibration is high can lead to waviness.
Oh yeah, that's true. So whatever related to this tool chatter or any these inclusions, as someone pointed out, these will give this will decide the surface finish factor. Whereas this machine vibrations, or is there any intermittent machining, or is there any jerk during the machining process related to machine that gives to waviness. So you can see the scale basically. So as someone pointed, this micro scale is something related to surface, whereas this macro scale is related to waviness. Okay. And someone also pointed out the spacing of two successive. So instead of that, I can just suppose I can see this wavelength. Suppose in surface finish, this is the wavelength, and in waviness, this is the wavelength. Okay. I think there is some okay, now you are getting. Okay. So this is something related to surface finish and waviness. Now we will talk morely about the surface finish and what are the parameters that we use actually to measure the surface finish, and what are the common mistakes that we do while solving these numericals. Okay. So before that, so as you can see, there is two topics I guess give, flaw and lay. So can you give me the difference between these two? What is flaw and what is lay during machining?
Is lay the pattern that is created on the surface due to, it depends on the machining operation.
So that is flaw or lay?
Lay.
Okay.
Lay.
Yeah. So what is flaw? So as you pointed out, this lay is something that you get, the tool marks that you get on the surface. Suppose if I am doing the shaping operation, so I can easily get this type of that lay marks. Whereas if I am doing any some random operations, suppose I can get in this direction, or else I can get something like this. The lay mark of the tool is something, the marks of the tool is something related to the lay, whereas this flaw is nothing but some surface defect that was presented on the surface. Okay, so we have certain notations for this for denoting this lay, as I am writing here. So okay, I just wrote two notations for this lay marks. I will write more when I'm explaining these symbols. So there was some surface finish texture that you want to know. So when I'm explaining that, I will explain these marks also. So as I'm discussing earlier, I said that there are two. We measure something related to the datum line or datum surface. So as I said, there are some system to establish datum also. So generally there was two types of datums two type of methods for establishing this datum line or surface. So anyone remember what are those two systems? M and E systems.
Yes.
Okay.
M and E systems.
Okay. Can you tell me what is M or what is E systems? So I have drawn two diagrams here. So basically this line is nothing but this is the datum line, that R0 line. So I have drawn this line in such a way that whatever the area occupied by these peaks on the top is exactly equal to the bottom, or exactly this line is exactly at the 50% of this this profile. Okay, and the other one, the system I'm talking about is that, so we take some 25 mm So these systems is nothing but different countries follow different systems. Accordingly, we discussing these systems. So generally, so in the other system there will be 25 roller in which we just roll that on the surface and we track the center of the circle, and this is our date, and we adjust this whatever this profile exactly at the 50%. Similarly, whatever I have done in the earlier system, I will adjust this 50%. Instead of a straight line, here I have the profile of the surface. So by doing this, so I will eliminate this waviness factor. So these are the two systems that I want to discuss.
What is 50%, sir?
So that 50% is the area. There are some numericals. When you do those things, you will get much more clarity.
In second figure, sir.
Similarly, so this is the ideal line that I have drawn. Then I will adjust that line here similarly, something like this, in such a way that the above and below area is 50%. Instead of straight line, I am taking here the profile, which looks complex, but the usefulness is the elimination of this waviness.
Sir?
Yeah.
Sir, in M system, is it always straight line or it can be a bit?
This is straight line completely. So this system is also called as center line average method, or the mean line method. So it's completely straight.
But in E system, it will be a wavy.
Yes. It's wavy, or it's an envelope, you can say. The system E system is also called as envelope system. This M system is nothing but mean line system. Okay. So these are the two systems.
Yes, sir.
If there is any question, you can easily answer. So now let us come to this the main parts that I am discussing, that is the methods to quantify this surface roughness. So one is the peak to valley height. So before that, so the general observation of a surface is, when you observe any surface, not macroscopically, it looks flat and smoother, but when you see the this microscopic level, we always end up with this type of profiles. I'm just drawing some random profile. So this is each profile. So if I take this, so this might be some random profile I have drawn. So we end up with a peak and we end up with the valleys and different types of profiles. So now, so there are certain methods to quantify this surface roughness. So now the first method that I want to discuss is the peak to valley height. It is nothing but this distance, peak to valley height. Okay. Then comes the central line average method. Anyone remember central line average method?
Sum of the distances to the number of people.
So sum of observations I can
Or
see.
the sum of area by.
Sum of the heights from the mean line irrespective of the its signs.
Okay, okay. So let us fix with this the sum of the area divided by L, because there were some good number of questions on this based upon this formula. Okay, irrespective of any geometry, this is the value, that is the sum of the area divided by length. Or even you can take the peaks and valleys into count also. I will discuss more about this ELA. Let us see some of the other things. So methods to quantify surfaceness. The other one is the root mean square value or the 10-point value. Uh, you know, and we have form factor, and we finally end up with this the measuring device, that is the tally surf. Okay, and this tally surf is nothing but the device. I'll just explain this quickly. So suppose this is the surface, this is the skid, okay. Yeah, I think the network issues from mine. So there were some network issues. So I'm just explaining this tally surf very quickly. So this is the actual diagram. So we will have a skid here in order to protect the probe. That is, this is the probe, and we have a fulcrum here, and accordingly when you move this tally surf, so we will have a movement here and here, so which changes the voltage, or the generated the voltage generated in this circuit, that is the Wheatstone bridge, and we will correlate this with the surface measurement. So this is a simple device tally surf. So this that we use for determining the surface profile very accurately and very fast, instantly, I can say. Just by scanning the surface, you will get the all the values of this quantifying surface roughness values. So so the importance of this tally surface, you just have to remember. You don't have to remember the mechanism. You just have to remember this name, tally surf. So they might ask you like, what are the devices used for surface roughness, and they might give these options. That is useful for this. Okay. Okay. Let me discuss some of the concepts in CLA also. Just give me a moment. My sound వస్తుంది. ఇంతమంది అసలు 8 వరకు లేట్గా స్టార్ట్ చేసా 8-10 మళ్ళీ ఇప్పుడు లేట్ మళ్ళీ టైం పడుతుంది. ఓకే. Black or blue color. Yeah, sorry. So now I'm discussing the CLA value. So there was one more formula I can write for the same. These are the notations that we use generally for this. And for this peak to valley height, generally we use our Hmax. So these are the some of the notations that we use for this type of measurement values. Peak to valley height are RT, Rmax, Hmax. So you might be familiar with this Hmax. I will discuss in a while. Then CLA or RA. So this RA, if someone has given me this in terms of some some function, so in that case I will just integrate this over the entire length. Okay. In case I don't think this type of questions was asked in GATE, so you might have okay, you can practice this well. So if they have given you any function value, so you can easily integrate it over the length and you can get the surface value divided by the length. So you have to remember this. So this is one more formula for this CLA value. And suppose if they have given you this values from the datum line, suppose say this is H1, this is H2, that is the peak and valley heights, H3, H4 and so on. So in that case I can just add these values, H1, H2 and so on, HL divided by N. So this is also one more formula. And then so this is a little, I will explain in some other ways. So right now I'm explaining the CLA values. So there were some so many formulas for this, but the basic remains same. Okay, suppose I have this random profile. So now they have given me the values of this shaded area. So in that case, and they also given me this cutoff length, that is L. Just yeah.
So actually here the sign convention doesn't matter, no sir, if it is a peak or level.
In
just
this,
add the magnitude of
yes, exactly. Yes. So this you have to add the magnitude only. So the sign will not play any role. Okay. So then, so these are some of the formulas, and as I'm explaining here earlier. So anyone remember this Hmax formula in machining? in metal cutting?
Yes, sir. Yeah. R by 8R, sir.
Okay, what is F1? What is R?
Feed rate. R is the nose radius of the tool.
Okay, nice. So this is the peak to valley height, or H max value. There is one more value formula related to this geometry of the tool. Remember?
In terms of the
Side cut and yes, side and end cut cutting. Anyone remember?
tan side cutting gauge plus
Okay.
cot of end cutting gauge.
Okay. There is there is some relation with this H max and RA. Okay. Just H max by 4. So that is one more relation. So these are the some of the formulas you have to remember. If they have just given you this H max, and if they want to calculate RA, this is the formula. Suppose they have provided you this nose radius and this feed rate and nose radius, this is the formula. And if they only gave this angles and feed rate, this is the formula in order to find this RA value. That is the central line average value. Okay, these are the some of the formulas for this central line average method. Okay, then let us continue with the other one, that is the root mean square value. So this is also nothing but this signifies it is under the root. Okay, so this was the formula for the root mean square value, and then this 10-point value, also called as RZ. So this is the average of 5 highest peaks as well as 5 highest valleys. Okay, this is the average of 5 highest peaks and 5 deepest values. Just take the average. Okay, so that is the 10-point value or the RZ value. So these are the some of the notations. So I have provided you here. What is the peak to valley height, CLA value height, root mean square value, and 10-point average value. So there's the major formulas that you need to remember. So there might be some other formulas also, but these are the main things that you have to remember. Okay, then so this is something related to this the quantifying surface roughness. So there were some questions, I don't remember whether they are in GATE, but there are some questions in other exams such as ESC or some competitive exams related to this surface roughness texture. Form factor.
Sir,
Yeah.
what was notation for root mean square? RG?
Yes, RG.
Okay.
Sir, actually, in case of root mean square, also only the magnitude matters.
Yes, of course. So you have that, we have square also, so it doesn't matter. But you have to take only the magnitude everywhere.
In 10-point average, sir, 10-point value.
Of course, magnitude.
Okay, sir.
Okay. I will discuss this form factor a little bit later. So let me discuss about these symbols that I was talking. So there was, as you can see, first of all, this is the concept. So the symbol. So if you have only this two unequal lines at some equal inclination, if it is given, the meaning is that it may be produced with any method. Suppose if it is completely closed, material removal is required. Suppose there is a circle in it, so that means there is no material, no need to take any action. So these are some of the terms that we use in industry for identifying the type of action that we need to perform. Okay, so now come to the main thing that I want to explain. Suppose if you take any one of these, suppose like this, in here I have written. So there will be some terms given. Suppose I have given like this. Something I am writing here. Suppose 0.1, 0.2, 0.35, 0.67, 0.89, 0.5. Some values I have written randomly. So, but you need to understand what values these corresponds to. So first let me explain this part, then we'll see the other one. So this is the part. So whatever they have written in this area, that is completely related to the surface roughness height, the maximum and minimum. So whatever they have written here, that is completely related to waviness. The right side will be the maximum value and the left side will be the minimum value. Sorry, the maximum waviness height and the maximum waviness width, the right side. Similarly, here they will give the roughness width of cut. So that what is the sample length that we use for calculation. And here we will get the maximum roughness width, and here we get the symbol. So that the symbol that I'm talking earlier, the flower symbol that I will get here, as well as here in this area I will give the machining allowance. Means how much material allowance I have given for this machining, and somewhere here I will mention the type of the machining that you want to perform. So these are the complete details of the thing that I want to do. And so this is the lay mark, you can say. So if you want to see this, what are the types of lay mark, if you give this equal to, that represents parallel lay mark. There is any perpendicular symbol itself denotes that's the perpendicular lay mark. Suppose if you have this type of wiring, so that is the circular lay mark that given by capital C. Or if the lay mark is pointing toward the center, that is the radial, that is denoted by R. Suppose we have the knurling kind of thing, then we give X, that is the crossed lay mark, and multi-directional lay mark, which is given by M. So there is no particular direction in that case, which is the grinding operation. So these are the different types of lay marks. You need to remember, just by seeing that graph itself you can come to know. Just remember these notations. M is like multi-directional, X is like crossed, R is radial, C is circular, and then the perpendicular as well as parallel. These symbols equal to perpendicular, here CR, here XM, and these are the values that you need to remember exactly. There is no way to there is no shortcut for remembering. Just have to practice if you want, and then remember. So in exams, they might just give, as I explained here, they might just give this type of figure, and they might just ask what is 0.2 what is 0.2 means, or what is 0.89 indicates, like this. Here you go. So these are the type of questions they might ask. So you have to remember this, as well as you have to remember this also, these three things. So apart from this, one more thing is there, that is the inverted triangles that we use. So this is one of the inverted triangle. So this corresponds to I am giving in terms of CLA values. So the surface roughness or surface finish should be in the range of 8 to 25 microns. Suppose if I have two inverted triangles, the surface roughness is limited to 1.6 to 8. Okay, and similarly, if I go on increasing these triangles, the surface roughness that that range or the tolerance in terms I can say will decrease. Suppose if I have say 4 inverted triangles, that is less than 0.0, extreme tolerance, that is 0.0525 microns, extreme surface finish I have to maintain. So these are like you just have to remember inverted triangle resembles the CLA values. If the triangles are more, then the surface roughness is minimum. Okay. So these are the some of the symbols or surface roughness texture I can say that you have to remember, and the type of measurement techniques that we use here. So this is something related to these surface finish measurements. Okay.
Sir?
Yeah.
So, what is the difference between the two? Can you kindly go to the page, sir? Like, show the two types of
This one.
measurements. No, yes, sir, this one.
Okay.
Actually, on the left and right, we have two types of.
Yes, exactly. I just.
Is it given together or is it
No.
separate?
No. Everything is together. So there is some space limitation. That's why I kept two separate. So in the right side figure, you can see the machining allowance, surface pattern. Only these two are missing in the left side figure. That's why I have written. So the complete figure I could not find anywhere. Some points are at least missing. Suppose in this left figure, this machining allowance is missing, but machining allowance will be in that place only. Okay, this is one figure.
So in that case, like on the top, we have production method. So like here we have
Production method. Yes. Production method I can write in a little above also. That I wrote is here machining type.
Okay.
Okay. So don't confuse. It is one figure. So and you have to remember the both the figures. Okay. And what is the meaning of this? I have already given here in the top. So these are the some of the concepts related to this surface finish. We can discuss some problems, one or two problems, and then we can discuss more on the next class. We'll see how it goes. Okay. Yeah, you can try out this. So some questions somehow related to the last class also I have kept here. You can just try this. Then we'll see what is the correct one.
Yes, sir.
Okay. Okay. Anyone post this previous year this recording link once?
I'll post it.
Okay. So what is the option? C.
A.
A. Okay. Nice.
A.
Okay. Just if you remember this, if we just draw this diagram, it is straightforward. So we have this 255 mm length, and then we have a this this rollers. So the distance between the rollers is nothing but this sine board, is 254, and then we have this triangle of 30 degrees. So if you use this, you can get the value of this opposite side. What is the value? Calculate the value of this value.
Which one is
120.
The triangle, right? The blue color one. This is 120.
127.
Okay. $127. Okay, then later it is straightforward. So this is the 127, and we need height from here. So how much you have to subtract? Okay, no need to subtract. Directly you can add, because here we have this R value here as well as here also. So you can just add this directly, 76.2.
Sir, one thing I have to ask you that here, why are you calculating 254 sine 30 degree? So calculating one
Sine 30. So in order to get this this height.
No, sir, it can we can get this automatically, right, sir? H1 minus H2 by L and equal to sine 30. Then
H2 minus H1 by L
H1
is
minus equal to sine 30.
okay. Is it?
Yes, sir. Here L is 254. And
Okay.
we don't know the value of H1 then.
H2, right?
Yeah, H2 part.
So if you do it, you are getting 203.2.
Yes.
Okay then. Yeah, that is also fine. I just want to see in this example like this. That's it.
Okay.
Sir,
Yeah.
so actually, in case the options are not given, so for example, here they have given one end, no, sir. Like we can also assume it as the other end, like the smaller dimension. So how can we understand it, sir? Like which side it will be, the smaller side or the larger side? 76.2 given.
Yes.
Okay, the idea of the is sorry.
Sir, actually, this one side and other side, it's seeming a bit ambiguous. Like which side it can be? It's given one end and other end. Like
Okay.
if the option is not given, it will be a bit more confusing. Sir.
Okay. Yeah, I got your point. So instead of this diagram, you are saying like one more small here and is this one? Okay. Yeah. So maybe they will clarify in the question itself in that case. The smaller height, the larger height.
Yes.
Okay. Yeah.
Sir, here roller radius should be added. Na?
See, here it is more and here it is less.
So, for instance, one thing that if they have not mentioned that which one is like in larger in height,
Yes.
higher, then
Yeah,
we have
that's
to calculate the both, right, sir?
Yes, you have to character both. So they have to mention in the question. Otherwise, or else they have to give the options. So the other one who is asking why we are, removing this. You got it, or so H1 is measuring from here. Since we are already having this, so we are not removing this side.
But 240 sine 30. This gives the value from center of one roller to center of another roller.
Yes, exactly. This side only. Correct.
From that vertical height, we added 76.2. But there is lower roller's radius is not there.
See, so this is the height, right? Suppose let me notate is AB. Okay, now in order to get this height H value, I have to bring it down AB to this, say this level is C, right? I have to move it down, completely hold the AB stick and just move to CB values. So how much I am reducing?
Okay, so we have already considered.
Yes, exactly. So that's why it is direct. Okay, so we'll solve one more question on surface roughness. This was previous gate question. So before that, just tell me what is H max here?
4 micron.
Okay. So can I directly do this?
Sir, I didn't understand this.
I'm just asking. So I got the H max 4 micron. So can I calculate RA directly like H max by 4, which is 1 micron? Can I do this process?
No, sir.
No. Why?
No, sir. The
Because they have given 2 micrometer and at 5 mm. We should use other formula, right?
Okay. So this formula I should not use since I have complete picture in my question. So I have all the peaks and number of peaks and cutoff length, everything is there. In that case, I should not use this formula. Instead, I should use the other formula. So that is the sum of these lengths divided by n. Okay, so don't confuse in this. I just want to mention. So whoever is started with this Hmax, don't do this. You do this only if the profile is not completely given to you. They just provide you the Hmax. Then you have to calculate RE directly. But if the profile is given to you and every values is there, then you should proceed with the other formula. The master formula, I can say the RE is sum of the heights from the center line divided by the number of observations.
So if the number of observations are same on both sides,
Okay.
then
It doesn't matter.
Can't we write the answer directly?
Yeah, you can write directly.
Same, right?
Yes, we can direct. You can write.
Then the answer would be 2 micron, right, sir?
Yes. Yeah. It's 2 microns one side. So everyone is getting 2 microns if you do this. So
Yes.
I think there will be 17, I think, if I'm not wrong.
Yes.
These values.
Yes, I counted it. So therefore, I'm telling that if there is like odd, then we have to calculate, and if the both sides are same, then we don't need to calculate. Like just put the value of that.
Yes, correct. Yeah. So this is the calculation.
Sir, so here what was the conclusion? That if the upper and lower boundaries are known, then just take half.
You need to count. Suppose what if they missed, suppose in some question, what if they missed these two? That you have to count. Otherwise you can do the same. You can directly take the half. No issues.
So for safety, we should count.
Yeah, better. We have 1 minute of time completely, so I can utilize.
Sir, and when will it vary? Like, for example, if one more extra is given on the top.
Yeah, you can just add this one more extra here and here also. That's it. Nothing will vary. Any questions on this?
So actually here, won't we need the thickness of each one? Like, of course, like here, the total thing is known, but the individual thickness we need to know.
Yeah, thickness is not given, so that is why we are directly proceeding with these peaks. If thickness is given, you can directly use that formula. Sum of the area by the cutoff length L. Okay. So, any other questions?
No.
Okay.
So I have 2 questions from the previous sessions.
This question.
No, sir. From the previous sessions you did, I had a doubt from that.
Okay. Yeah, let us discuss. So if there are no questions, the others can leave. We can continue the next class. So I can discuss the more numericals on this and the mistakes that you can do. So meanwhile, you can. So the theory part I have covered. Meanwhile, you can just go through the previous year questions and you can solve. So you can directly attack those questions.
Okay.
Yeah. If there is no doubts, you can leave. So those who are having questions, you can stay. We can discuss.
Okay.
Yeah. Someone is saying previous session, right?
Yes, sir. So just like if you just explain the topic, it's like enough, sir.
Okay, which topic?
Not exactly slide wise, but as a based on the topics.
Okay. Just tell me which one.
Yes, sir. Actually, in case of bilateral tolerance, if we have equal tolerance on both sides,
Okay.
so in that case, what will be the deviation?
So there is one shortcut, like you can directly add these tolerances in bilateral if they are of same kind. If they are of the other kind, then you have to take care. So that was one concept I remember.
So because both are equal and close, no, sir?
Yes. They are equal and alike.
So anyone is answering.
Sorry.
Yes, sir. Exactly same distance.
Yes.
So anyone can be the answer, no, sir? Like upper limit or
I don't remember actually, but you can you can make it out easily.
Sorry, actually in this case, which means it will be either upper limit or lower limit, or it is anyone's.
Let us see. You have any question with you? Because I cannot formulate right now.
I don't have a question, sir.
Okay. It is straightforward. I think. I think
like
I have left it for
minus 0.05. Sorry, sir.
I think I have left it for homework. I think that bilateral of same kind, something like that.
Yes.
Yeah. Okay. If you have questions, if you remember any question, we can discuss. Otherwise, you can easily make it out. It's simple only. Okay.
Okay, sir. What is the use of dial gauge in?
So this dial gauge, it is used so many situations. Suppose if I want to measure, suppose this the height measurement for a simple case, this it will have this dial gauge, and I will know the least count, and I will count how many degrees it moved, and I will get the height. Okay, this is useful. Suppose if I have I want to measure machining of. Suppose assume this as a check. And this is the workpiece. Suppose if I want to machine it, before machining I have to ensure that this surface is flat. So for that case I will put the dial gauge here and I will just move it around this side and this side, so that I will know that this surface is flat, means straight, not flat. The surface is slight with respect to the machining bed. So this dial gauge will be fixed to the bed of the lathe. So that is the reference I am taking. So that is one of the useful. Yes. Yeah. Any other questions?
Yes, sir. Actually, if we have interferometer and optical flat, what is the difference exactly? Because we discussed them both together. Separately given interferometer and optical flat.
So optical flat is nothing but the device that we put on the workpiece, and we use some microscopes to see the fringes formation. That is something to deal with the optical flat. And interferometer, I don't exactly remember this working principle, but can you name any device under this interferometer? Because this optical flat is one of the instrument that actually works on the principle of interferometry.
Yes, sir.
So the basic principle, I think I have explained in the last class at the end. It is something related to do with the this. Suppose this is the workpiece length, and we have some theta deviation, and this is the optical flat. So when you pass this light, it will have a refraction as reflection as well as refraction, and finally it will go here and it will read. So this is the distance, so that I am naming it as PQR. So based upon this this distance, and if the theta is too small, then I can directly take this PQ is equal to QR is equal to this n lambda. Sorry, PQ plus QR is equal to n lambda, and PQ QR are equal if theta is small. So in questions also you will see the for a small theta angle. So in that case QR is equal to n lambda by 2. So this is the basic principle that we keep in mind finding this flatness error with this optical flat. This is the basic principle of interferometry.
So PQ and QR we are taking approximately same.
Yes, for small theta angle.
Yes.
Yeah.
And finally here we are finding only the QR parts.
Yes, and yeah, QR are one more thing is there. So this lambda or this n number of fringes. So this depends actually on the source of light. So if for suppose this lambda, if the path difference is, so there is one term called this path difference. If this path difference is 0, you will get like bright fringe. If the path difference is non-zero, you will get this dark fringe. So something to do with this also. So based on that, you will get this lambda value also. Yeah. And one concept is remaining on this interferometry, if I remember. Suppose you have an optical flat and you have a convex surface. So in this case, at the center you will not get any fringes. It is dark, and the outer side you will get bright and dark fringes. So this is called bull eye. This occurs when you use this type of surface. This is optical flat. These are not required per gate, but you can just remember. Suppose so what happens if I keep convex sorry, this is convex, this is concave. So what happens in concave? What type of pattern I will get? Any idea? Yeah, sorry for that. So suppose if I keep this optical flat on concave surface, what type of pattern I will get? Can anyone guess?
Circular with bright.
What happens at the center? Bright or
bright?
Bright. Actually, it is no. It may be bright or it may be dark. Depends upon this whatever I said. This lambda values, this wavelength of the light that you are using. So it depends on that. If at the center, if the lambda is such that if it is destructive interference, you will get dark or otherwise bright. But in concave, it is always black. Yeah, that is one small topic remaining.
And one more question, sir. We explained like these things was like different types of surface roughness.
Yes.
How do we compare the values, sir? Like which is larger?
Yeah. You tell me. This peak to valley height is something like coarser, so it will always be at the end. Means the other side, which is larger, whereas this RA value, this CLA value is the minimum value. R is
the minimum.
No, this root mean value also will be even lesser because you are squaring and taking under root. I think there is one sequence I can give you in the next class. I don't remember exactly now. I'll give the sequence. But Hmax, I'm quite sure that is the final one which is having the higher surface.
Yes, sir. We have some calculate formula or something like it's just.
No, it is general observation. Or in formula also you might know, but this is a general observation, you can say.
Okay, sir.
Okay.
So actually, the first question answer was not clear for me, sir. Like the bilateral tolerance one.
Okay,
Like,
okay.
Will you be taking the next class, sir?
Okay, I will take it in the next class. Just remind me. I will take it in the next class. That bilateral. I will find if there is any question.
Case, yes.
Okay, sure.
Thank you, sir.
Okay, thanks. So any other? Yeah.
Sir, regarding last time when we were solving previous year question,
Okay.
2015 gate, there was doubt in the answer.
Which question?
Regarding the limits. The go gauge and no go gauge, sir. It controls the upper limit and the lower limit.
Yeah, okay, that question. Yeah, I remember. So what's the doubt?
The two of the options were correct in that.
Both are correct. In the gate key I have seen, they have not given both correct. Only one they have given correct. Is it so?
Yes.
Okay.
You said you will tell it in this class.
No, I have discussed in the last class. So I have seen that gate paper. I went to that website. I have seen. So the correct option is like that only for the go gauge, whatever is which controls the lower limit of the hole. That is the correct option. And the other one, that is the no gauge, which controls the upper limit of the hole. Sorry, lower limit of the shaft. Sorry.
Okay.
So that question, so the only one option is correct. That is go gauge controls the lower limit of the hole. The other option is not correct, since go gauge is completely inserted into that certain product, and it ensures that the value is correct, whereas no go gauge will not enter. So it corresponds to that whatever the value, it corresponds to the lower limit of the shaft or whatever, but it not exactly controls. So the other concept is this no go gauge is like one parameter measurement. It just measures only one value, whereas this no go gauge, it measures multiple values. Like I said, the roundness you can measure, the ovality you can measure, as well as the dimension you can measure. So it is like more parameters that were involved in this no go gauge. So that was just an explanation. If we can find better explanation, you can just let me know in the next class.
So go gauge controls more parameters.
Yes. It's like 3-point measurement, you can say. Whereas no go gauge is only 1-point measurement. Just measures the dimension.
Thank you.
Yeah.
Thank you, sir.
Okay. Yeah. Thanks for attending.
Sir?
Yeah.
Thank you. Sir, actually, I forgot to ask this one question.
Yeah.
There are actually a bit confusing between the autocollimator, spirit level, and like few devices which measures as flatness.
Okay.
Is there any distinct significance between even this interferometry? Like everything is measuring the flatness and.
Yeah. So it depends on the usability. So spirit level is something I can take anywhere, literally, and measure. But autocollimator is, I cannot take everywhere the setup. Whereas spirit level is something to do with the macro, bigger length scales. Whereas this autocollimator is something related to the even smaller. So autocollimator is nothing but you are going this surface in micro level, whereas the spirit level is this broad level, you can say. The length scale varies in these things, but the parameter remains the same. It measures straightness if you take in one direction, and it measures two. If you take two directions or more than two, it measures the flatness.
Yes, sir. Actually, there are a lot of devices in Prisma. So, like, should we remember any extra other than what we discussed?
No, these are main. So autocollimator is one of the main you can remember. Spirit level and the other one, that is straight edge. There are there are no much questions on that, you can say.
Yes.
Okay. We'll meet in the next class then. Thanks for attending.
Thank you, sir.
Thank you.